Meetup site. So I hope everybody's aware of is okay with that. So very quickly, what's PyData and what is this meetup about? So we are part of the outreach program of NumFOCUS, which is a US-based nonprofit that promotes open source software and open science. And as part of the outreach program, we organize regular meetups and have also organized conferences in the past. And we are in general about promoting open source software, promoting open and scientific use of data, and promoting these practices and spreading the news about these tools. We are 4 people that are organizing the meetup as volunteers. Federico, who will join us later, Joris, who's also on the call, Leandro, and myself, Ole. And we are all doing this as volunteers, so as a side activity. And a quick word about NumFOCUS. So NumFOCUS is a umbrella organization and financial sponsor for many open source software packages. If you look at the list here, you're very likely to see a name that rings a name and that you have used in the past. So, very well-known packages like NumPy from the Python world around there, and SunPy and Jupyter and Pandas, all the big names, but also non-Python languages such as Julia. So they're really doing an awful lot in terms of promoting these projects, supporting them financially with scholarships. So if you in turn want to support these projects as well, then please do consider a donation to NumFOCUS. There's a link at the bottom, and I'm going to say a bit more about the various ways that you can support them as well. Another quick thing, code of conduct. It should be really just common sense. We cannot tolerate any insults or put down. The general theme here is, be kind to each other and behave professional. Any sort of harassment or sexist, racist, exclusionary behavior is not appropriate for PyData, and we cannot accept. If you feel that something hasn't gone quite right at a meetup and you feel that there has been a violation of the code of conduct, you can contact the Code of Conduct response team. That's all the organizers. I'm going to put our emails out at the very end, but we have also like an external contact person if you're feeling more comfortable to speaking to someone who is not part of the meetup. And her name is Leonie. Her email is mentioned here at the end. And you can, of course, go to NumFOCUS directly if you feel like it. A few community updates. We are looking for speakers to present in 2021, next year, basically. So if you're interested, please step forward and contact us, email us, contact us on meetup.com, tweet to us, do whatever is most easiest for you, but yet now do step forward. I can only say it doesn't have to be a sophisticated, it doesn't have to be a very long talk. We can really accommodate all sorts of formats and ways of presenting. It can even be something as short as like a quick presentation of your favorite open source tool or some data analysis that you did recently. So, don't be shy. And you can, of course, you're welcome just to email us with some very rough ideas, and we are happy to sort of like ping back and forth ideas for a talk and help you to put some more shape into it. So that's all a possibility. Again, I mentioned NumFOCUS and their financial support for open source projects already. They are running a fundraising effort, an end-of-year fundraising effort. It's a program where basically external supporters of NumFOCUS match donations that are coming in between now and the end of year up to a certain amount. So basically, if you donate $10, there is some other sponsor will match that donation and put another $10 in, up to a certain maximum amount, of course. So it's a really great thing to do. And if you have some spare cash, consider doing it. There is also a so-called telethon event by James Powell, who is on the board of NumFOCUS. If some of you have been to PyData events before, like conferences or meetups, James Powell is a really regular speaker at PyData events. He is kind of like a walking Python reference book. He knows the language in and out, and he's a very, very good speaker. So he's running this live coding and lightning talk presentation, which runs this Saturday at 7 p.m. GMT. So my understanding is that he will do some live coding, and he's going to join by a couple of big names from the open source and Python community. So, and it's like a fundraising event, so you can join that, and in the course of this event donate to NumFOCUS. But overall, I think it's going to be a really, really fun event, and I would encourage you guys to take a look at it. Okay. We spoke already quite a bit about money. I'm going to speak a little bit more about it. We, the Meetup, are also indebted to our sponsors, and I wanted to highlight them here. So these are all companies that are, well, with the exception of NumFOCUS, these are all companies that are local to Cambridge in the UK, and they're supporting us in various ways, for instance, by paying for our Zoom licenses, for Meetup fees. ARM and FetchAI have paid for pizza many times when the meetup was still happening in person, and Raspberry Pi, the Raspberry Pi Foundation, to be precise, is our venue sponsor. So these are all great companies, and not only because they are supporting us. If you are interested in them and talk to them in any ways, then please do mention that you heard about them at Pydata Cambridge. That really does us a huge favor, and it's going to help us tremendously in recruiting more sponsors and getting any sponsorship contracts that are already exist renewed. So please do consider that. Since I mentioned jobs, so these are updates from ARM. They are as I said, they are headquartered here in Cambridge, and the business of chip design, in particular, specialized on energy saving chips that are frequently used in mobile phones. Have a look at these job advertisements. There's a lot of interesting stuff going on. If you want more information, please do reach out to Federico or Leandro, who will be joining the meetup later on, or go straight to the careers page of ARM. The Raspberry Pi Foundation, for those of you who have not heard about them, they are the guys that are making these mini and highly customizable computers. So that's this Raspberry Pi computer that is very popular among students, but also digital makers. And the Raspberry Pi Foundation is running a lot of educational program around this Raspberry Pi platform. So here's the link to their educational platform and to their programs. If this is something that interests you, please do check out their programs. They are really very active, especially nowadays when they're not running any in-person events. Last but not least, FetchAI is also a local company, local to Cambridge. They are in the business of machine learning and decentralized infrastructure. If some of you have been to our October meetup, I believe, we had two FetchAI scientists give a talk here and explaining their ideas around running machine learning in a decentralized networks and using digital ledgers to exchange results and estimates between the machine learning models. So there is some really cool stuff going on around collective learning. If this sounds interesting, please do reach out to them. There's their email address and their Discord channel. I do know that they're also hiring regularly, even if they are no job advertisements advertised here on this slide. So, do check them out if you're looking for an interesting job. So last but not least, I promised to mention how to contact the Meetup organizers. As I said already, we are always looking for speakers. We're also looking for sponsors. So if you have job openings that you want to advertise, or anything else related to data and open source software, please get in touch with us. You can do that in various ways. We are on Twitter at Pydata Cambridge, or you can also email us at pydatacambridge@gmail.com. Okay, that's it. That was the introduction. Thank you very much for listening. If there are no questions on the chat, and I don't see any right now, then I'm going to hand over to Isaac, who is going to speak to us about deep time series models and their loss functions.
Okay, sure. Let me see. I'll get started here. I'll just throw up my screen. Oh, it says host disabled attendee screen sharing when I click share screen. Okay, so yeah, I think I can share now. Okay, I'll throw this up. Okay. So, everyone see my screen okay?
Yes, it's looking great.
Okay, let me see. Okay, so so yeah, tonight I'm going, tonight or this afternoon, my time, I'm going to talk about kind of finding the right loss functions for your deep time series forecasting models, or also just a little bit about Flow Forecast, which is an open source deep learning for time series framework that I'm the creator and maintainer of. Actually, it's good to mention I do like presenting at Pydata. We were, and our repo was recently actually just at Pydata Global, an official open source sprint there. So if anyone's interested in contributing, please let us know. And yeah, so okay, so yeah, I guess onto the topic, a brief introduction. So yeah, one of my major interests is kind of time series forecasting and also time series classification, in particular using deep learning models to apply it to real world problems. In the past, at some of my work, I've forecasted things like demand for retail items in stores for better store stocking, agricultural yields. And right now I'm working on kind of both forecasting both forecasting COVID and also some kind of other flash flood and stream and river flow forecasting. Yeah, one of my major interests is using deep learning models because I think they offer a lot of benefits over kind of the manual type of feature engineering for other models. And I recently gave, actually, if you're interested in hearing more about kind of deep learning for time series, I gave a talk at TWIMLfest. I don't know if people are familiar, but it's a podcast where, but anyways, it was basically an hour long, and I went into detail about why it's not used in industry a lot, deep learning models, and how it can be. I don't have time to obviously go over that all here, but that's kind of a lot more detailed view of some of what I'll be talking about tonight. So I've also given talks on reproducibility best practices and kind of how that formed the basis of our open source project, Flow Forecast, if you're interested in that. So yeah, onto the main subject for tonight. I assume the majority of people here are familiar with time series. forecasting, but if you aren't, and kind of the general kind of metrics and loss functions if you use, but if you don't, here are kind of three of the more common ones. There are others too. We have things like mean squared error, which is basically, as the name implies, just the, actual minus predicted squared, and then you take an average over all the different time steps. You have mean absolute error, which is just basically the absolute value also averaged over the time steps. You have mean average percentage error, which is very similar to MAE, but just expressed as a percentage, which some people and some business folks like because they're familiar with percentages more. But so these are common, probably I'd say the three most common ones I see a lot. And particularly when coming from, I guess, research, you don't often think a lot about what metric you choose. Usually there's another paper that's already like tested a deep learning model and they use one of these metrics. So you're just like, oh, I just have to show my model performs better with this metric than this paper. But when you're doing stuff, particularly in industry or applying deep learning models to real problems, it becomes really important which metric you choose for evaluation for a whole host of reasons like explainability to stakeholders. Maybe the data is like very messy and one of these doesn't work well, which I'll talk about in a second. And then sometimes even in research too, it can matter because some of these actually used as a loss, as kind of the loss will cause weird things to happen when you're training your model, which I'll talk about in a second. So yeah, using these, I've run into various problems, so some more than others. So yeah, I'll go on to common problems. This is not my diagram. This was actually the diagram from a paper at NeurEPS 2019, but I think it illustrates stuff well. Basically, here's like common mean squared error. And basically, I don't know if people can see these, but essentially in each one of these graphs, the mean squared error is actually exactly the same. It's like 8 through all three of these. So, and obviously if you look at these, this one probably is not a good forecast when you actually plot it out. So this kind of reaffirms this point that sometimes you could get a very low like mean squared error, but then when you actually plot, your forecast versus actual values, this isn't great. Whereas of course this one is exactly the same mean squared error, um, but it's obviously fitting the data much more. There, as this mentions here, there's just kind of a time delay. So basically, one of what this paper proposed, and I've actually we've implemented this in Flow Forecast too, that you can train models on, is called the dilate loss function, and basically it takes into consideration both the shape and kind of time delay. So here you can see that here the dilate loss is significantly worse than say here or here. But the dilate loss is essentially the important part too is essentially two main components, which is the shape and the time component. And yeah, I have used it, and as I'll show from some actual examples in a minute, sometimes works well. It sometimes works well, and I definitely like the idea of it more than kind of MSE because particularly with some of my stream and river flow forecasts, you get a very good MSE value, but then you go to plot it and it's like entirely, the forecast is essentially doing something similar to this. So anyways, that's kind of an overview of some of those common problems and at least one loss function that can help with those. Another thing I like to use a bit is mean absolute scaled error. It still has some of the problems of MAE, but it also helps a lot with particularly if you're comparing things of different magnitudes. I know R squared is used a bit for this too, but I think MACE is better both kind of as an actual loss function and an error metric. It's actually what one of my colleagues at Monster recommended to me a while ago. back when I was working there. But anyways, basically the idea is you just have the mean absolute error, and then you divide it by of the model. So this would be like the mean absolute error of the model, and you divide it by kind of a naive baseline. And this is nice because then essentially it's scaled. So like if you had, say, like two products, just as an instance, at a store, and one sold a lot, and you wanted to test, and the other didn't sell a lot at all. So like one, say you had like 1,000 sales a day, and the other you had like, say, 10 sales a day, and you wanted to find a model that was good at forecasting both the sales for both of them, and could perform well equally, then you could essentially even take, using MACE, you could take the performance on product one and directly and the performance forecasting product two, and say like average them together, because this is essentially giving you a scale over kind of the baseline. And it's also interesting because you could essentially use anything as your baseline, as I'll say in a second. So you could even use a fairly good other model, and then that really will force the loss to be like really compared to like another method, rather than just kind of um, the actual well, it still uses the actual values, but it will like definitely scale it in proportion, so you won't like wind up with really huge losses if it's a very hard problem. So yeah, and I've also found it's good for seasonal stuff as well. So with that said, now I'm going to talk a bit about our open source framework. So Flow Forecast is basically a deep learning for time series forecasting framework developed by myself and several others, written in PyTorch. We have a bunch of kind of the very modern like deep learning for time series models. We actually make it our mission, like as soon as like a good model comes out of a conference or something, to very quickly implement it and import it to our framework. On more of the reproducibility side, we make it very easy to use configuration files to track experiments and hyperparameters. We're integrated with weights and biases, so we have easy hyperparameter searches. We also have cloud integrations. So in particular, we're very integrated with GCP, so you can reference data directly in buckets and spin up instances using Flow Forecast, very easy for that, and automatically save your weights, config files, and stuff to GCP. We're working more on AWS integration. But I guess related to our topic, using these configuration files, we also make it really easy to like swap in and out different loss functions to see how your models perform. So yeah, it's kind of our framework, and I'll run, and actually, so now I'll leave slideshow and show a couple different examples of some of this stuff. So yeah, as I said, we basically log everything to weights and biases. So this was a model, I think this was one of actually of our COVID forecasting models, essentially trained using standard mean squared error. You can see loss pretty much goes down, and then validation loss is a little more wonky, but that's in part because we had a very small validation set because we don't have a long temporal history for COVID. We do use early stopping, so we actually our framework automatically restores the weights back to the lowest point with validation loss. But anyways, one of the things I was going to show is like the difference between training a model with the different kind of things. Now, actually, all these models performed fairly well, because these were actually pre-trained using extensive transfer learning and then using metadata from locations. So none of these performed that badly, but this is an example of like one of the models trained with mean squared error. And here you can see, well, we use confidence intervals as well. Flow Forecast makes it very easy to use confidence intervals. But I guess then like one of the things you see is like, is like, this kind of gets some of the shape, but it's kind of hard to tell because the confidence interval expands here, whether it actually like, this kind of looks like at this point with the COVID forecast, there's kind of a downward trend. So by the way, it's this orange line that's the actual values, and then it's the blue line that's our predicted one, or well, one of the predicted ones, and then the confidence interval. The confidence interval is constructed using dropout essentially. So we just run the prediction a bunch of times with dropout. That's kind of the CI for it. So that's just kind of an example. And then, as I said, we use, but probably more importantly, we use these kind of different, as I said, configuration files. And the nice thing about this with weights and biases is then our full configuration file is essentially logged here. So what happens is essentially, oh yeah, this was actually root mean squared error ever, but that's just essentially the square root. So this was like the forecasts on it looks like a county in Texas where we were forecasting, and this was kind of the root mean squared error. This is the model name, and I'll show you where you would actually enter these parameters and stuff, but that's kind of the overall view of that. So yeah, and then we can look at another one where, for instance, we use MACE. You'll immediately see like that the way the loss looks is a bit different, though this is pretty similar since there isn't a huge difference. I think if we go down, by the way, all these other charts I'm scrolling through are basically our interpretability plots. So we automatically log a bunch of interpretability charts so people can see stuff. But we can see that this looks a bit better training with MACE here. Confidence interval does seem to more envelop this whole area, and kind of the stuff does trend a bit further downward. At least it looks that way. It would of course be good to plot these all out more, but it does look like, just based off this graph, that MACE encourages a bit better predictions in this area. So yeah, and then I don't think there's too much of a difference between MACE and the dilate loss, but whatever, you can like certainly see that. Yeah, loss with dilate sometimes is a little harder to converge. That's why I've seen, because dilate loss, because it takes those components into consideration, it is larger. But I think in the end you do see validation loss to like does do a more steady downward stream overall. These were kind of hard models too. You don't see really smooth curves because the data set for COVID is obviously very limited. It's a very new disease. Oh, I guess the one for dilate loss actually didn't work as well. But so that's interesting. But I guess one of the big points here is the two that just is that depending on the loss function, you might want to experiment with a bunch of different loss functions and then kind of track how they work. And that's why we make it really easy in kind of flow forecast to do that. So so yeah. So here you see, here's the configuration, and there's dilate loss. So I wonder how I'm doing on time, but anyways, I'll just quickly show what kind of one of our training notebooks looks like. This is actually for training one of our river flow forecasting things.
You still have 5 to 10 minutes if you want to use it. Sorry, just because you asked.
Okay, yeah, I just wasn't keeping track. So yeah, that sounds good. So basically here, here, as I said, we define all of our models by configuration files because this works really well for reproducibility purposes. And as you see, these are logged to weights and biases as well. So this is the example of kind of creating a configuration file. But literally in most cases, as I said, like changing the loss function is as easy as just changing this in the configuration file. So this is currently using root mean squared error. If I want to use say like the dilate loss, I just change this to dilate loss here, and then this would train using the dilate loss, which is nice. If some things like MACE, for instance, if you wanted to use MACE as your loss function, they do require like a second set of parameters for what the baseline method is. So you can see I just had this comment out here, but then I can actually specify what the baseline method is. So here it's mean. You remember with MACE, because it's like the mean absolute error over a baseline mean absolute error. So here it's mean. So this just means whatever the mean is in that forecast history that's passed into the model, it will use as kind of the baseline method for that. We are working on having others, so you could potentially even use another model here, and then that would be kind of the quote unquote baseline method. But so yeah, that's kind of how it's very easy to just switch back and forth between loss functions when using kind of our setup. I'll just change that back to RMSE. The second thing you can do is you can actually log multiple metrics too when evaluating. So I'm not sure if I did any of the ones here, but for instance, like if when evaluating, you can have like evaluate and add both like MACE and the dilate loss or something. I'll see quickly if I did that here. Yeah, I don't think I did it in this one per se, but if you had multiple ones here, they'd appear one right after the other in terms of evaluation, so you could then see it. I might have one, where is it back here? Oh yeah, so here's one where I had it, one run where I had it. So say here's dilate loss, and here's RMSE, so you can kind of see what both look like. And then if you run a parameter sweep, so this is actually a parameter sweep where we're sweeping over different values for batch size, learning rate, forecast history, forecast length, number of encoder layers, since it's using, it's basically stacking various self-attention blocks and dropout rates. So then you could, wait, where'd that one go? So then like, as I was saying, you could, I got confused by my windows. Oh yeah, here, but here's like an overview of a sweep, like you'd have say 36 runs, but then all I was saying here is then you could pick the metric you want to sort the runs by. So you could, for instance, here, sort the runs by dilate loss to see the best with the dilate loss. Or if you wanted to, you could sort the runs by the, by RMSE as well and see the best according to RMSE, and just, explore which ones are those. That's one of, I think, the good things about being integrated with weights and biases, which is actually also another open source and free to use framework. So yeah, that's kind of the overview of our stuff. We really like using these configuration files because in a similar vein too, this doesn't apply just to say, like the loss function. Either you can swap a bunch of stuff in and out. You can swap the optimizer as well. So you could use Atom or SGD. You could even swap the model though then. So if I wanted to use a different model, I change the model name to whatever model it is, or then swap out these parameters, et cetera, to match whatever model parameters. Though then I would have to modify the sweep because there are some ones like the encoder layers dependent on that. So that's kind of the example of that. And yeah, as I think I mentioned before too, we do have these interpretability heat maps. So yeah, this was another one of our COVID ones. There are a bunch of different ones, but for instance, here, I don't know if this was a very good model, but looks like it was mainly paying attention to the previous cases and the mobility of parks when making its predictions. In reality, it probably should have been using more of these other features, but it seems like it weighed these two very heavily. Though yeah, so I mean, the predictions aren't the best, but worked okay. So yeah, again, our repository is just called Flow Forecast. We're on GitHub. We're licensed under GPL free, so we're definitely committed to being an open source. So if anyone's interested in using it, we do have extensive documentation, or if you want to contribute, we're always looking for contributors. So yeah, I think that sums up my talk. Does anyone have any questions? Oh, Q&A, I guess.
Yeah, thanks a lot for the talk, by the way. I think there was someone who was asking about the URL for the podcast that you mentioned at the beginning. Is that the right one that was posted here on the chat?
The URL for which?
The podcast that you mentioned.
Oh yeah, the overall the one where the long talk I gave on deep learning for time series. Is that
yes.
Yeah, so I can post it here if anyone's
Okay.
if anyone sees it. Wait, where's chat? Oh, chat's there.
In the Zoom client.
Okay, yeah, here it is. Yeah,
Okay.
yeah, it's on YouTube, so anyone can see it. Oh, I think I see an answer here. Or a question? Do you use input only discharge data? Yeah, so for the river flow forecasting, basically what we use is precipitation, temperature, and river flow data. Right now, we're also working on integrating gauge metadata, so like what elevation it is, what latitude and longitude. Those are the primary free. Actually, this is a good opportunity, I guess, to show. So like say if you, with our framework, we have a different like, you can take whatever columns you want from a CSV. So basically in your data loader params, the columns you want to use, you basically specify. So here we specify relevant columns are the cubic feet per second, the precipitation and the temperature. And then the target column is the cubic feet per second. So that's kind of how our data set params work. And if we were going to use other things there, we would just add it as kind of, I don't know, we don't actually have soil moisture now, but if we say had a column with soil moisture, we just add the column name and then it would be used here. So.
Cool. Thank you very much. That looks really like a lot of work. Oh yeah, okay. I see another question here by Paul, also in the Q&A. Do you still have time to answer that?
Yeah, sure. So yeah, I think with Mace, Mace, I think the advantage is that like it's kind of, in particular, it's basically scaling to whatever the baseline method is, even if it is a complex model. So for instance, like in some of these river flow cases, it's very hard to forecast stuff, particularly when rivers that are dam controlled and they might release dams at arbitrary dates, even on no seasonal patterns. So if you have, so the problem is particularly with standard loss functions, your loss could easily kind of explode, so to speak, by getting some of those predictions wrong. So one of the nice things about Mace in using like another model with it is then it will at least be scaled with respect to, with kind of respect to that. So there is some benefit. I think if you look at like Robert Heinemann, I think is the one originally proposed it. He has a good, more further reference on that. So.
Okay, thank you very much. I see there is another question from Krish, who has sent it only to the panelist. So Krish asks, is it possible to reproduce the same result as shown using the documents and GitHub, please?
Yeah, I mean, we have this, we have the reproducibility stuff, so we log the config, so you should be able to reproduce it using the same config, and then the notebook. I don't know if we've put all of our notebooks on GitHub. We've used a lot of them, but the core framework, and there are examples of notebooks there. But yeah, if you want to reproduce it, it should be reproducible using the same config, and then since that's what matters. There is sometimes randomness, basically in random seeds with both NumPy and PyTorch. We're trying to reduce that now, but for the most part, you should get pretty much the same result if you use the same config and the same configuration file and you know, same setup. So.
Okay, very good. Yeah, I was really impressed by the framework and the level of diagnostics plot that you produced there. That was quite neat to see. Let's see. I don't see any other questions on the chat and the Q&A. Maybe taking a step back, just one very last question. We have a lot of people that are very interested in like a machine learning and data science career. Can you maybe tell those people that are at the beginning of their career a little bit how you got started and sort of like, you know, what steps you took to get involved in deep learning?
Yeah, sure. So yeah, for me, I guess it really was, I did take some coursework in college, but I didn't do anything that heavy or anything. So for what I really learned a lot, particularly doing like computations on Kaggle. And then after that, I really learned a lot just by trying to find interesting projects, and then making them open source. So for instance, some of my stream and flash flood research just started by I paddle whitewater a lot, so I wanted to know like when the stream would be flowing. So it's like, wait, that could be a good machine learning project. And so I really learned a lot just by kind of finding interesting projects and working on them. And I think open source contributions are an often underrated thing, because if you have like a lot of good open source contributions, then you have like basically a footprint like on that any hiring manager or anyone can see. So at least for me, if someone has like a lot of good open source projects that I can look over and see their code and how they interact, I might not even give them like an arduous coding test because I've already seen kind of some of their stuff. So I always find that useful, would be my advice, I guess. So.
Yes, I can only echo that, sort of like having visible code out there on GitHub or anywhere else where it's visible is really very useful, and a good sign for good coders. Yeah, that sounds great. I think I cut your introduction a little bit short at the beginning. Sorry about that. I think I read somewhere that you're also involved in a PyData chapter in Maine, in the US. I think it was in Ono. Did I remember that correctly? Do you want to give a quick shout out to your to our sister or brother PyData meetup, and are there any events coming up that you want to highlight?
Yeah, sure. So I mean, for a while I was the organizer. I still organize a bit for Pydata Orno, which is kind of a small community in Maine. We're definitely a smaller chapter of Pydata, but we since we're kind of in a rural area of Maine, but at the same time, we've had a lot of interesting talks on machine learning and forestry and other kind of industries that affect our area, agriculture as well. So yeah, feel free to check us out on the Pydata page as well. We haven't been too active recently just because it's been hard. I think, like yourself, it's been hard for us to get speakers. And yeah, feel free to check us out or volunteer to be a speaker if you're interested in presenting to a US crowd, I guess. So.
Great. Okay, thank you very much, Isaac. That's yeah, thanks a lot for the talk. I have not been able to locate the second speaker, so it's very well possible that this is the end of the meetup. So one last shout out to Dan Roythorn. Dan, if you're among the attendees, if you dialed in and I didn't see it, just post to the chat, and you would be ready to go. But yeah, I think that means no. Okay, so Dan has emailed me about an hour ago and said he had some scheduling difficulties tonight, so he could probably not make it. And I guess this means that he's really not been able to join. So yeah, very sorry to anyone who was looking forward to his talk about Gaussian processes. I think that was his theme. So we are just trying to, get him in at some point in 2021. And I guess that's it for 2020. I hope you guys had fun. And if there's anything that you want to tell us about, any feedback or proposals for talk, we are always very happy to chat. Do read out, on email or Twitter. I'm going to post the introductory slide deck or the link to the introductory slide deck on the Meetup page, so you can find our contact details there. And that's it. Thank you very much for dialing in, and enjoy the rest of 2020 and have a good start into the next year. I hope I'll see you at one of our meetups next year. Bye-bye.